Thank you. Okay, we can start earlier today so we can go earlier for lunch. Nice. So sorry for the delay. I'll try to go quickly. So my name is Ignat. I work for Cloudflare. Who here knows about Cloudflare? Ooh, nice. Who doesn't? Not many people. Just ask your neighbors. So in short, Cloudflare makes websites faster and secure for free. So you can try to use it, and it's very nice. I advise you. But today we're going, and by the way, in Cloudflare we do a lot of Go. Go. Most of our internal code is written in Go. So if you like Go and you're interested in working, we're hiring. Check out our careers page. We have many people from Brazil. Not many, but we have some people from Brazil. So it's all nailed down. Okay, so today we're going to speak about how to use Go as a scripting language in Linux. First, a little about myself. So I'm on performance and security team at Cloudflare. So I dig into performance issues because we promise you websites will be fast. If they're slow, we don't keep up the promise. And I'm dig into security issues. I work mostly on platform infrastructure security, so it's not related to customer security. I'm passionate about security and crypto, and I enjoy low-level programming, and that's why I actually enjoy Go, because Go provides me with this trade-off. It's low-level enough for the things I need to do, and it still like allows me to not to do all the C memory management and things when I do my task. Okay, so why would you want to use Go as a scripting language? And, and here it should be easy for me now, because when I present the same idea at other events with generic developers, they say like, oh, but why do you want to do that? We have Python, we have that and this. But because it's GopherCon and you all like Go, I hope I don't have to persuade you to that Go is a cool language for scripting. So I'll not uh, spend much time on that. But still, why Go can be useful as a scripting language? Well, it's easy to learn, write, and read. Like, as I remember, some other speaker asked that. Who uses Go as their second language. So there are a lot of people which started using Go and that was their not first language, but basically all of you probably can say that it took you just a couple of days to start writing in Go, right? Who took like months to learn Go? No one. Yeah, see? So it's easy to learn. So, and if you have an average sysadmin, they can start writing Go in no time. Secondly, it's huge ecosystem of ready code. One of the reasons Go is so popular because there are a lot of third-party code out there. You don't have to code everything from scratch. If you need to do some complex tasks, there is probably someone else solved it already. You can just go get your dependencies. And unlike some other scripting languages, to go get third-party code, you don't need any administrative privilege, so you can do it as normal user, which is very useful in an administration scenario, like in a multi-user environment, and you don't have to give users elevated privileges so they can install their dependencies. It's compiled and strongly typed. How many of you had this scenario when you need to perform some complex task on your system to transition it from state A to state B? You write 1,000 line bash script, start executing it. It executes half of the script and then errors out because you had a typo somewhere in the command. And you're left with the inconsistent system because you didn't go from state A to state B, somewhere in the middle. Hopefully with Go, it will be less common because it's compiled. So before you execute your script, it will be compiled under the hood. And if there are some typos, hopefully will compiler will catch you. So it will lower these chances. So unless you have some flaw in your logic, your scripts will be transactional, right? And finally, it's like, which is important for me, as I mentioned, it's low level enough for system tasks. So I don't have to deal with C nowadays to do all the low level things I need. And it's also, and if I do have to go to the C level, I can do some minor parts in it, and I can just stick C code into the Go file, and Go will pick it up automatically. So that's very handy. What are potential use cases for that? For example, if you have a complex Go project, you will likely need some kind of build system, so because Go build will not be enough for you. But why have this build system, like use makefile for your build system, or even worse, Python, where you can have a Go build system instead. So you have your Go project and you have your Go system. It's all like self-contained in one language. Another potential use case which I like is quick Go prototyping. What, like, I sit in the office and then I come up with this crazy idea and I want to quickly verify it. I open my editor, start typing some Go file, but then to check if it works, I need to save it, compile it, run, then I realize I missed something, and like iterate. So what I want to do is, like, I want to quickly modify the file and immediately execute it to see if my concept is working. Some people agree that's not a reason. So for them, like in Cloudflare case, for example, we have 6,000 servers, and it's rarely that we use a single script to manage all of them. So we're using a config management system called SaltStack, and instead of scripts, we use scripts templates, and a config management templates your script to each specific use case where it executes them. So if you keep your scripts in program compiled format, you will not be able to template them. So like keeping your scripts in source format gives you the ability to template them later, and which is very important for a large scale management. And what are others? Like probably anywhere instead of Python. So like people use Python everywhere. Go is very similar in Python. It has a lot of third-party code available. It's easy to read and write. So probably anywhere you're using Python for scripting now, you can try to replace it with Go and see if it brings you some benefits. Okay, now how do we execute the file? So let's go to the basics. What do we need for a proper script to work? So we need an operating system, we need some programming language, and we need an interpreter for that script, right? So for the purpose of this talk, we use an operating system. As an operating system, we'll use Linux because it's the operating system. I don't know if there are any other operating systems, real operating systems available. So yeah, programming language, we use Golang because it's Go for Con, right? And the question is, what will be our interpreter? And like, if you're familiar with Go, from the top of your head, you will say like, oh, we have gorun. So gorun can run .go files for us, right? So let's see if it's appropriate. So let's write a simple toy Go script. It's just a plain Go hello world program. If you can take anything from this slide, is please keep in mind how to properly write hello world, because many people provide incorrect spelling of hello world in the example. So hello world always starts with capital H, has a comma, and has an exclamation mark on the end. So if you're doing some examples for your colleagues and do not write like this, you're doing it wrong. Yeah, let's try to execute this program with gorun. So we just we do gorun, our Go file, and we see our hello world. Great. But scripts need more than that. Like, what do we want from a proper script if we're using in real world case? It's usually one script to parse command line arguments. The second thing we want from scripts, they should return proper error code. So if there is an error, there are predefined error codes, and we want them to return to the operating system the proper error code, because rarely we use scripts on their own. We usually bundle them in some kind of a weird pipeline, and the error codes are the way how programs or script interact with each other and the operating system. And finally, what we want from a script is we don't want to type go run or Python every time. What we want to give an executable bit set the executable bit on the Go file, and we just want to execute our Go file, and we will see our Go run, right? So let's modify our toy script so we can test all these assumptions. So our version 2 will parse a single command line argument, and if we send it a magic command line argument fail, the script will fail with error code 30. Why 30? It's chosen by random, so don't try to put any meaning on it. It's just 30. It's just not 0, right? And how do you make scripts executable? So the typical way of doing this on a Unix-based system is you add a so-called shebang line, which is, does anyone don't know what a shebang line is? Oh, for you. So it's the first line in any script. It usually starts with a hash and an exclamation mark, and it provides your path to the interpreter, which should be used to interpret that script, right? And what it essentially does, it tells the operating system which interpreter to use for that particular script. Now, some people on internet say it tells you a shell which interpreter to use. It's not correct, and I will explain it later. It tells you operating system. Keep that in mind now, and you will see the explanation later in this talk. Okay, so let's add a simple shebang line to our Go script. So it's hashtag and pass to our Go binary, and we'll add it go run. So we try to run it. Let's try to execute it now. If you try, you'll get this and this output. So what happened here? The problem here is, unlike other scripting languages, hash is not a valid command in Go. Like, on the contrary, it is a command in Python, it is a command in Bash, right? And it does even work in Node.js for JavaScript, although hash is not a valid command for JavaScript. But Node.js had made a special exception just for the shebang line that ignores the first line with a hash. But gorun doesn't do that exception. And people ask for it online. Say, why can't we use gorun? Can it ignore the first line and some other requests? But Go maintainers say gorun was not intended for that, but they didn't explain actually for what it was intended. So if Cassandra is here, so this is a complaint for her. So can we bring clarity what gorun should do? If not, execute the scripts. Yeah. So if we have a problem, right? Complex problem which there is no ready solution. So we ask the community, right? And we go to Stack Overflow. And what smart people on Stack Overflow came up with is like, okay, we can deal with that. We can exploit the special behavior in most shells. So in most shells, if you don't have a shebang line, and the shell would just try to execute your file, text file, line by line as shell commands, right? And they also exploited the fact that in Unix system and in Linux in particular, the double / in the file system path is equal to a single /. But double / conveniently is a command in Go. So what they came up with this simple, it's not a shebang line, but I call it a shellism line, which exploits the properties of a shell. So it calls go run, and they also add these weird numbers as well, so it can parse command line arguments as well, right? So let's verify how it works, and we will try to pass a command line argument now to see if they were correct. All right. We do see our output line. We see hello script, right? But there is some garbage appended. So what happened here? The script was executed, which is good, and parameter parsing worked, which is also good. The bad thing is then the shell, after executing the first line, and exiting from gorun, tried to execute our source file line by line, tried to execute package, it tried to execute main, and everything. So, and it can't process it, so it errored out. Yeah, so people on Stack Overflow don't give up. They say we can we can deal with that. We can add another thing. We can add an exit after calling gorun, so we immediately terminate the shell and not start executing line by line further, which is nice. Let's try it. So yeah, parameter parsing worked. No garbage output. Nice. Let's now try the fail scenario. Let's tell the script to fail. And if you do that, you will see your hello fail, which is expected, but you see some weird output appended with exit status 30, which is not in your script. And if you check the real exit status, what was returned to the operating system, it's 1. So what happened here? The script was executed, good. Parameter parsing worked, good. The shell terminated properly, good. The bad thing is, again, gorun. Gorun, for some reason, masks the real non-exit error code from your Go programs. It adds an extra output with your real error code, but returns 1 to the operating system always. And again, the maintainers say it should be like that, but nobody clearly explains why. So, and people ask to fix this, but they push back. Stack Overflow, people say, we can deal with this as well. So we can modify our shellism line. I didn't put the whole proposal which they proposed there, but it's just like explanation in pseudocode. So they say, okay, we will parse. If the output line has an exit status, we will consume that line from the output, parse it, return the real exit status to the code. But like at this point, I think it's just too complex, right? So Go was designed to be simple, and Go scripts should be simple as well. But this doesn't go with the whole Go architecture, right? And if you put this crazy string in your script, and when you hire new people, they will just be confused when they will first see this code, like compared to normal shebang line, which is nice, right? Python, very simple and understandable. And even if you go this road, which is not explained online, but it's my research, that you still have a major drawback. So if we go this road, let's try to execute our script again. So the typical success case, it works. Now, let's try to execute the same script, not from the shell, but from a different program. For simplicity, I use Python, but it can be any program which does exec system call on your script. And if you try it, you will see this. So what happened here? You will see an error from the operating system, exec format error, which means that the kernel, the operating system, could not parse your executable format. It doesn't know how to execute this file. And to understand what happened here is we need to dig a little bit into Linux internals. So what happens when some user process tries to execute another process? So it just does it by calling a system call called exec, and it passes that the thing it wants to execute. So in this example, for example, it's some Python script. So this exec system calls gets forwarded to the Linux kernel. And in Linux kernel, there are different modules which are usually prefixed with binfmt name, which are responsible for parsing different executable formats. So we can see that we have a binfmt out, which can parse out executables. We see our familiar binfmt elf, which can parse elf executables. And if you're executing a script with a shebang line, it goes forwarded to the binfmt script module. And binfmt script module is actually the module which is responsible for parsing the shebang lines. So that's what I told you before, that shebang line processing does not happen in your shell. shell has nothing to do. The shebang line parsing happens inside the kernel. And when the kernel parses the shebang line, it extracts the path to the interpreter, and it starts a process for you with this interpreter. Yeah, so shebang line processes happens inside the kernel, which was a surprise for me as well. And the problem with shellism approach that shebang line happens inside the kernel, so no matter which environment you use to call your script will always be executed because the operating system knows how to execute the script. Unlike the shellism approach proposed on Stack Overflow, the processing happens in the shell. So if you try to execute your script from outside of shell environment, you have no shell to process the first line, and the operating system does not know how to process your .go files, and it just fails. So shellism is crap. Let's throw it away. Let's try again with the shebang line. And what we know so far, gorun is no good. It doesn't return exit status code properly and cannot process or ignore at least the shebang line. Shellism line are not good because they're cumbersome and non-intuitive. They do not work outside of the shell, and they exploit the properties of most shells. But this behavior is not standardized, so there might be some shells, weird shells, which do not even do that. So it might not work in some shells. But because Go maintainers refuse to fix gorun, as it always happens in the open source world, some guys came up with a third-party tool which fixes the thing which maintainers refuse to fix. So we have a custom program called gorun, right? It's just spelled together. So what is it? This tool was built to compensate the lack of scripting support for gorun. It consumes and processes, mostly ignores the shebang line, so it will not error out on it. And it returns proper exit status. Okay, so let's try our script with a proper shebang line, but this time we'll call our custom gorun tool, and let's verify if it works. So parameter passing, nice, works, no extra output. Failure case, you see the expected hello fail, no extra output, and if you check the exit status, you see 30, which is what expected. Let's try to call it from another program, from outside of the shell. It will work because now the shebang line processing happens in kernel. Kernel knows how to process this file. And finally, now when let's say we use the use case for quick prototyping. We prototype some script, and now we want to compile it. We're satisfied with the result, and now we want to compile it to a real Go program. And we use go build on our Go file, and it will fail. Why it fails? Again, because we have a shebang line, but hash is not a valid command in Go, so the compiler also fails here, and they cannot process, the compiler cannot process your Go file. So we were so close, right? So we almost did what we want, but that still we have this minor issue that like prevents us from having all good use case, right? And yeah, so then I started, can we try a different approach? If we cannot provide an environment for our operating system to use Go language as a scripting language, maybe we can modify the operating system to support our environment. So let's go back to how Linux executes files. And we know it has different executable parsers. And it seems like we have an elf parser which we can't use. We have a script parser which we can't use. But there is an interesting parser called binfmt misc, which basically translates to anything else, right? So, and I became interested in this parser, what it can do, and it turns out the binfmt misc executable parser can be configured from user space to add custom executable formats by the administrator. So yeah, so binfmt misc, it allows registered custom interpreters for specific executables and scripts. And you can specify these executables either by file header or by an extension. So it's very similar to functionality in Windows where you can register a program for a specific extension to be called when you click on the file with that extension. And surprisingly, for kernel module, it has pretty good documentation on kernel documentation page. So if you're interested, take a look at this link. It's described in detail how you interact with this module. So I'll give you a quick 101 here. So the way you interact with the module is through a special virtual file system. So first you need to mine this file system. If you are using a recent modern systemd-based Linux distribution, you don't have to mount the file system because systemd will mount it for you. That's great. And the second thing you do, you describe which files, you describe to the operating system which files the system should interpret and how to interpret them. And the way you do that, you generate a specially formatted string and echo it to that magic file called binfmt register. So let's see an example. So first, we just verify if the binfmt misc file system is mounted. So if you run this command, you will see a similar output if systemd mounted the file system for you. And here is an example how to ask that module to interpret your Go files. So if you see the string contains several segments separated by column. So the first segment, Golang, is basically your tag, is your custom name, how you want to name your extension. The second large E means we want to tell the operating system to specify files by extension rather than the file header. And the third segment, Go, it just tells which extension it is. Because we want to execute .go files, we need to say E and Go. The next segment is a path to interpreter the operating system should invoke when it encounters that file. And the last section is flags. I will not go deep into their details, but they are needed here. Just read the documentation. Why do we need those special flags? And the way how it works is, so user process will try to execute our Go file. It will forward the call, make the exact system call with our Go file. Because we registered .go files as a registered format in binfmt misc, that call will be forwarded to binfmt misc kernel module. The kernel module will read this extension. It will verify that it's indeed a .go file. It will find the registered format and parse that line and will extract the path to the interpreter which it should use, and that it will execute that file via interpreter. So in the end, you will have a process which will be something like that. So it will be passed to your interpreter, which is gorun in our case, and it will pass the file for us to that interpreter. So let's try it. So this is version 6 of our script, and it's with nothing. You may notice that it has no shebang lines, no shellism, no custom things. It's just a plain Go program, which can parse arguments and return exit status. So assuming we registered Go format, as I explained earlier in the binfmt misc kernel module, we can execute the file with a parameter. It will work. We can ask it to fail. It will fail properly and return our error code properly because we execute via custom gorun, and gorun does it okay. Now we can try to build this file, and it will build okay because there are no hashes there. There are no custom quirks. It's just a valid Go program. You can just build it. And again, if we try to execute our script from a non-shell environment, from another process, it will work again. Because the processing, as with shebang line, the processing happens inside the kernel. So the kernel knows how to execute our .go files. Yay. So what we learned today is hopefully Go may be useful as a scripting language. Do you agree? No? Nice. Unfortunately, standard shebang line is not compatible with Go just because the hash is not a valid command in Go. Gorun was not intended to be used as a proper interpreter for .go files, but we have custom tool gorun. And binfmt misc is a neat Linux feature. That's why the talk is called using as a scripting language in Linux, because it's Linux specific. It's a neat Linux feature which can solve the above shortcomings and turn Go into a truly scripting language. And the one thing I didn't mention, what you can take away from this talk is you can replace Go with any other language you want, and you still turn them into a scripting language. You can do scripts in Rust, C++, Haskell, and any language of your choosing. And you may even notice that, for example, on Debian-based distributions, the operating system already registers some formats for you. You can find a registered format for Python files. So if you forget to add a shebang line to .py file, it will still work because of binfmt misc module. You can always execute. You can also execute jar files without invoking the Java directly. So you can just put executable bit on them, and they will work as well. And here are some useful links. So the first link is the original blog post, which inspired me doing this research. And this blog post describes the shortcomings of the classic gorun tool, introduces the custom gorun tool, but it stops at the point, but we still can't have a perfect solution because gorun scripts are not compilable. And that's where my blog post picks up, which is a second link, which says, no, we can if we use binfmt misc module, and we can have an ideal perfect solution on Linux, and Linux is the operating system, so you don't want more anyway. And finally, I just repeat the link for the if you're interested in binfmt misc kernel module, link to the kernel documentation, how to interact with that. Thank you. Questions? Questions? The usual question I get on the non-Go conferences, but why? No?
No.
Lunch?
Yeah. Thank you very much, Ignat, for your talk.
Thank you.
For coming. And a round of applause.